Problems that involve computational geometry can be quite confusing at times because when you think of a problem in terms of when you're writing code, it's kind of hard to picture something with a curve when you're talking about code, right? Things are quite straight-edged or square, rectangular. They have tight corners, right? And you think in terms of matrices, you think in terms of these. However, when it comes to computational geometry, oftentimes you are thinking of many shapes, many different types of shapes, and how they interact with each other. This problem is kind of a really good example of that type of challenge when it comes to computational geometry. You're given an array of points, and you are to find how many of those points lie within some other group of circles, right? So it's in an array. The circles are in array queries, and each of those elements in queries is xj, yj, rj, which tells what the point the circle is centered at with its radius, right? So in order to find this, what we need to do is iterate through each of these circles and determine if their distance between all the points in the points that we want under consideration are close enough to them that we can determine that they're inside of that circle. Okay, so this involves finding the distance between the center of the circle and the circles and the points, and then to determine what the distance, base the distance off of that and the radius to find out if the points lie within that circle, how many of them do. So first we're going to need a helper function that we'll call inside for points that might be inside the circle. We'll accept p for points and sir for the circle information that we'll iterate through our query. We'll compute distance, and the way we're going to do that is by using x1 minus y1 squared plus x1 minus x1 squared plus y2 minus y1 squared, all under the square root, and that is the common distance formula. So we say p0 minus sir for circle 0, okay, squared, and then what we'll do from here is we'll actually just do the exact same thing for p1 and sir1. So we say plus, and then we'll have p1 and sir1, okay, and then we take the square root of this, which is star star is 0.5, right, to the power of 1/2 is the square root, and then we just want to return if dist is less than or equal to sir2. That's the radius, right? The distance within the radius. Great. Res for result is the empty array. And now all we're going to do is say for sir in queries, c equals 0. For p in points, those are the points that we want to measure against the distance between that and the center of some circle, and the radius under consideration as well. We say if inside p sir, so that'll return true if it's within that circle, we want c plus equals 1. c plus equals 1. After all of those are computed, res.append c, and then of course we return res. We run, accepted, submit, outstanding.